Hello everyone and welcome to this presentation. Today we're gonna discuss computer-aided design, CAD, extensions of CAD, and CAM, computer-aided manufacturing. So first of all, um, this is a continuum of the design process. Okay, so yeah, as you can see, design of goods and services. So this is the whole design process, and we are continuing on CAD. So CAD basically is using computers to design products and prepare engineering documentation. We can use software such as AutoCAD, other software that are available, 3D softwares, are many software like computer-aided design softwares that are available now, and most of them do the job. But the important thing is that we need to first have a design. So they provide shorter development cycles and improved accuracy. It's very accurate. You can do it with the computer now. It's very accurate and the cost is very low. And information and designs can be deployed worldwide. So and there are some extensions of CAD. These include CAD through the internet. So there are some applications where you can use CAD through the internet, and also 3D printing. So 3D printing, computer-aided manufacturing, CAM, this is an extension of CAD. It utilizes specialized computers and programs to control manufacturing equipment, and it's often driven by the CAD system. So the CAD system drives this CAM system. We cannot have computer-aided manufacturing without the CAM system. Yeah, without the CAD system, without having uh, the computer-aided design. Okay, so then we're gonna move on the product documents. So what are the product documents that we are going to need? So they are engineering drawings, which show dimensions, tolerances, and materials. And also there is the bill of material, which is a product structure. It lists components, description, quantities of each component, and the materials required to produce each of the component. And it also states whether we are going to buy a specific material or make it ourselves. So it's very important part. Bill of materials, very crucial. It's like when you buy from IKEA or any other home, um, home provider, like furniture provider, where they allow you to assemble your own table or desk or whatever. They give you a list of the components, the screws, the quantities of the products, say the bolts and all of that, and they give you the exact quantities for each of them. And yeah, so it's also important to have an assembly drawing. How are we going to assemble this? Again, our same example, IKEA have their own assembly drawings attached to each of their products, and assembly chart. The road sheet, we're gonna go over those. So the route sheet lists the operations and times required to produce a component. So yeah, and then work order. And these are instructions to produce a given quantity of a particular item. And then engineering change notices, ECNs. So we have engineering drawings. As you can see, this is a drawing of a specific item that's gonna be produced by a company, and these are all the specific dimensions. And also you can see this is a top view, then this is a side view, and you can see all of the views of this component, and this all can be done in using software such as AutoCAD. It's one of such softwares you can make 3D CAD design. So, and as you can see to the right, we have some of the materials. This, if you can see it, it says the materials A2, heat treat, and others. Many information about this, the materials and this specific component. And now, as you can see, this is the bills of materials. Is very important, and the bills of materials, or for short BOM, is this is for a panel weldment. Okay, so as you can see, each number gives us each number represent a specific item. So for example, A6071 represent a panel weldment, okay, and the quantity is 1. Also lists the quantity that we need. Those we can notice there are letters AR, and there's one that doesn't have a letter, which is a bolt. If it doesn't have a letter, it means that this is we are going to buy this product. We are going to buy bolts, and the reason why sometimes we need to buy and not make things ourselves is that sometimes it could be costly and also very inefficient. We could produce a product that's not really reliable. So, for example, and there are other companies that produce some products that we need in bulk. They produce it way better, more efficient, produce it in very large quantities, and it's cheap. It's cheaper than if a company would produce because they have the expertise. They already done the job, so we can just basically buy it from them and then assemble it and or add it to our own um, you know product. So and yeah, so and the other materials just say that we are gonna make it if it has a letter like A or R. So we have also a workshop. Okay, so this is supposed to be a workshop, and each group is required to discuss. Okay, so you can discuss an idea for new app, and now this is the fintech um, period where it appears that the sky is the limit regarding like ideas for smartphones, tablets, and apps, and etc. So there are many in all sectors: business, health, education, sports, etc. So they are everywhere. So you can have an idea of an app. If you have an idea of an app, you can discuss it, talk it, even share it with us. Uh, uh, when you share ideas, you really make them grow. And so you can share it with us if you have any idea, or you can just discuss it. So, yeah. So we can go here. Okay, so there's a product life cycle. So each product have specific life cycles. Okay, so and it may be any length from a few days to decades. So some products are like trends. They come up in days or even weeks and then they disappear. And other products like um, can even last for a person's lifetime. For example, cars. Um, I was born with cars. I was born also with laptops. So these are products that last for decades, and there are products that last for a few days, like trendy fashion clothes and stuff like that. These last for very short periods, and so the operation function must be able to introduce usually new products. And if you don't introduce new products, then you're gonna be left behind. So, and here's the product life cycle, as you can see. First, we're gonna have, of course, on the y-axis you can see the profit or loss, okay, and on the x-axis you can see the phase of life cycle. So, as we introduce a product, we're gonna, of course, gonna bear some losses because it's a new product and no one knows about it. So we're gonna pay for the product, materials, marketing, and everything related to that product, and you are not expecting a profit at the beginning of your product, the introduction of your product. That's something to be expected. So, and this is basically the cost of development and production. So, yeah. And even when it reaches the growth period, the beginning of the growth period, you're still not gonna be making profit until sometime you break even, okay, and your costs equals your revenue, okay, and then this is gonna be the time you break even, and then after that, if your product is continues to be a success, then it's gonna reach maturity, and that's where you make your profit and your revenue exceeds your costs. So, and then of course, no product lasts forever. Products at the end decline, and then also profits decline with it until it reaches a point where it's really dead. So one example is, let's say some, let's say Nokia. Okay, their phones were in a rapid growth and they reached maturity, and now they are, of course, in the decline phase. And I'm not sure if they are making profits. So yeah, some products just go out of the existence, and if you don't keep making new products and expanding, you will certainly lose the market. So these are some components, say, or the process. It starts with the product design. So designers conceptualize, for example, here we have an example of the electrical car. So let's say Tesla, they wanna make a new electric car and consider factors such as aerodynamics. They're gonna hire mechanical engineers and also some electrical engineers and also people who are experts in this topic. And they're gonna discuss the battery replacements, interior layouts. These are all the specific details that need to be taken into consideration. They create sketches, digital versions, 3D models to visualize the vehicle's design. So this is very important. That's why AutoCAD and other softwares, CAD in general, computer aided design is very important, because since it's very convenient and it's very, very not costly. So very affordable for companies. Anyone who has ability who has access to the internet can basically create his own computer aided design. So, and then after the product design, you're gonna go to the process design. You're gonna design, develop the manufacturing process for assembling the electric car. So you're gonna design the let's say um, the factories that are the processes inside the factories that are going to make our electric cars forever, like with some maintenance, of course. But we're gonna develop these machines that are going to make our electrical cars. And so, and these are really like the ones we have for our regular conventional cars. And maybe they're gonna add other, of course, not gonna be the same as conventional gas cars. The processes, they're gonna be different since the components are different of the electric car. And so they design automation systems and the quality control processes to ensure that every car is like consistent with the other one, and there is a reliability in the production. And then after that, we're gonna go to supply chain design, and it's designed to source components. So each component separately: batteries, motors, electronics, chases from suppliers worldwide, logistics. So it sources components, and so networks are established to coordinate delivery of components to the manufacturing facility. So, for example, Apple doesn't make all of its iPhones components. They buy a lot of the components from other suppliers, and that's where the supply chain design is needed. You need to make sure you have all of the things that you need. You're not gonna make everything by yourself and design it by yourself and make it, because this is gonna be very, very time consuming, as not going to be efficient. So you need to depend also on other suppliers until the company feels it's starting to get independent, and they can start producing their own components. But at the beginning, they need to rely on other outer factors, and that's what very most companies do. And for that, they coordinate with established manufacturers to get some, for example, batteries, motors, electronics, chassis from suppliers, and that's the important part. After the process design, you're gonna go to supply chain, and then we're gonna go to the uh, plant control location. Sorry, the plant location is chosen. And it's chosen based on factors like the proximity to suppliers. That's very important. You need to be near suppliers to minimize transportation costs, and also access to skilled labor. This is an important thing. You have good labor around you. The transportation infrastructure also in the country and the place. Government incentives for manufacturing, and specifically green manufacturing. After that, after we choose the plant location, we're gonna choose our plant layout design. Okay, so engineers design the layout of manufacturing plant to optimize workflow and space utilization. So they design assembly lines, robotics, and storage areas. So in order to minimize like bottlenecks and maximum efficiency. Yeah, bottlenecks. Okay, after they design the manufacturing process and workflow and the space, the overall factory that's going to produce our in this example, electric car or whatever it be, like a mobile phone or printers or whatever it may be. So they designed that, and this is um, the planned layout design. And then after that, we're gonna design the job description design. This is important. We're gonna assign roles and for engineers and laborers, and make sure they have um, their job titles clear. And this is the job of the HR team. The managers create job descriptions for various roles within the manufacturing facility. So this includes assembly line workers, engineers, quality inspectors, and administrative staff. So these are all utilized, and the job descriptions are outlined. So for all of their responsibilities and the qualifications needed, and also the performance expectations for each position. So they are now basically defining what are the job titles in the manufacturing facility and for the product. So, and then after that, we're gonna go to the workplace design, and the workplace is just designed to provide a safe, comfortable, and ergonomic environment for employees. So we're gonna make sure our factory is safe for them and it's uh, not a dangerous place. Okay, so they want to live comfortable lives because they're gonna basically spend most of their lives in a factory. So yeah. So and features such as natural lighting and temperature controls, ergonomic workstations are all implemented to enhance productivity and employee satisfaction. So these are all made for the people who are going to work there. So this is the workplace design. We need to design a safe place. And now going to IE main decisions and activities. So industrial engineering main decisions and activities. There are a lot of decisions and activities done by industrial engineers. So that's why they are really one of the most wanted to say majors currently. So we can say we can list them. They go from 1 to 10. First, product design, process design, supply chain design, and facility dedication. Facility layout. This is what we discussed. So job description, work measurement, human factors, HR, production planning, inventory control, production scheduling, quality maintenance management. So there are also other things that we need to consider. For example, how are we gonna produce our products, how much are we gonna produce per day, per month, depending on the seasons, the needs of the customer. And again, we're gonna use some forecasting methods to predict the future, let's say, needs and demand, the future demand. So, and that goes all in the production planning. So, and we have inventory control. We're gonna control the inventory, of course, not to be short of products, and also not to be over producing products. And also there is the production scheduling, and this is basically scheduling the production of our item. It can fall under the production planning. Also, we have quality. It's important to ensure that we have satisfactory quality for all of our products, and then the maintenance management. Make sure we are well maintained um, overall. And then, okay, this is okay. So this is regarding sustainability packaging for food products. So if we are going to go specific and talk about sustainability, we can start, like, as an example, how are we going to uh, design a packaging for food products, sustainable packaging for food products. So the first phase is going to be the design phase. Designers will conceptualize the sustainable packaging. They will consider factors such as eco-friendly materials, functionality, and branding. So these are all conceptualized in the packaging. Also, we're gonna have the process design. So engineers will develop the manufacturing process for producing the sustainable packaging. It's an important. And considering methods for molding, printing, and sealing. They design equipment for quality control procedures. to ensure consistency and compliance with regulatory standards. So this is the process design. So basically, they need to consider the methods also used to make these packages. It's not only that the packages are recyclable, or let's say they uses sustainable, eco-friendly materials. Also need to consider the manufacturing process, because this is also part of their, mission. Their mission is to be sustainable. The let's say the factory or the company that's producing sustainable packages. So we need to also ensure that the manufacturing process is also sustainable, and we consider the different methods for this. And then we're going to go to the supply chain design. And the supply chain is designed to source eco-friendly materials such as biodegradable, uh, degradable plastics, recycled paper, or compositable fibers, and these can be imported from other suppliers. And then there is relationships. Relationships are important in the business industry and the supply chain, and they're important, and they are established with suppliers who adhere to sustainable practices. That's important. We want to have relationships with people who share our visions, our mission, and all of these. And also logistics networks are optimized to minimize environmental impact. That's important. And also minimize the carbon footprint for our transportation and our building of materials and stuff, and our process overall. And then there is the plant location. This is also part of the supply chain design. You can say they are closely related. The location is important to minimize costs and also minimize the impact. So the location is based on factors. Some factors are include raw materials, transportation, infrastructure, labor, proximity to target markets, also renewable energy, access to renewable energy. So, and also we're gonna consider local regulations on waste management. So, and then there is plant layout design. So engineers will design the layout for the manufacturing facility. Now we're talking about the facility itself, the factory, to optimize production flow and also minimize waste. That's important. As part of our mission, we need not to forget about this, because it's part of our mission. We cannot just produce things and call them sustainable, and our just and our you know our process design, the process design, and also the process of producing these materials is not sustainable, and we are producing a lot of waste. We are burning coal and burning fossil fuel, and then we say our products are sustainable. This is not something this is not a real mission or vision of a company. So, and then we go to job description design. We're gonna describe the jobs for, and this is part HR's role is to describe each job title, and have all of the you know um, the needed job titles for, so machine operators, quality assurance specialists, maintenance technicians, and administrator staffs. And job descriptions outline responsibilities, qualifications needed, and expectations for each model's position. So it's the same thing. And of course, we're gonna emphasize the importance of sustainability. Maybe we can consider the past effort of our employee. Is he um, participating in events related to sustainability and stuff like that? So, and then we have the workplace design, which is our last step, is to promote a culture of sustainability, and also so design the culture and also the facility to ensure that's safe for our employees and it's well established, and also it's energy efficient. It recycles waste, and also green spaces are incorporated to minimize environmental impact. So these are all important things. Okay, so service design. Now, if we are gonna talk about services. Now we were talking about a product. Now, if we're gonna talk about a service, so services are usually intangible. So these include banking, finance, health. Health you could consider tangible or intangible, depending on your review. Insurance is intangible. Transportation and communication. These are all intangible services. Also, fintech apps and online apps, online companies' websites that provide services. These are all intangible products, and these may require different approaches. And then services that typically include direct interaction with the customer. So you need to interact with the customer. And the productivity of it is notoriously low. And this is because of the customer involvement in the design or delivery of a service or both. So it could be hard to be productive in a service sometimes because the customer need to be involved and they sometimes want to change a design, change the service. They would not like the initial service there, so they would ask the provider of the service to adjust it and design it, redesign. So this could impair our productivity in providing services, and it sometimes complicates product design. So and this is something that's normal in providing services. And the focus on service design is on process chain, the focus on it, which is a sequence of steps that accomplishes an activity. So a process chain is a sequence of steps that accomplishes an activity, and this is our process chain. Now, these are the major steps in service development. Now we're talking about services, not product. We were talking about product, now services. So first, we're going to start with the requirement analysis, what the customer needs. Then we're going to talk about stakeholder analysis, the stakeholders, we're going to analyze those. Then simulation, we're going to simulate the service. Pilot study, we're going to do a pilot study, documentation, monitoring, and control. These are all parts of the um, or major steps in developing services. So we're gonna do all of these. These are all important. So and then there are some documents for services such as high level of the services in general require documentation. So because the customer wants some proof or some knowledge of what the service he's getting. So it might require explicit job instructions and scripts and storyboards and other techniques. So okay, this looks like a first bank compression, um, tiller service guidelines. So the guidelines are basically you should say please and thank you in all conversations. These are guidelines for this service. So drive up tiller service. This is a service, of course, when you um, reply to people's inquiries and stuff like that, like killer service. And some of the guidelines include, so this is an example of we want to develop a service. You need to be discreet when speaking into the microphone as others may hear the conversation. Give customers written instructions if they need to fill out forms, you give them. And if you are meeting customers directly face to face, then you should look directly at customers if there is a line of sight. And if a customer needs to bark and enter the bank, apologize and continue. So these are some guidelines for our services. We're gonna develop guidelines here. So you know which is part of our service. So and that's all for today. Maybe we have some notes that we can go through. So this covered QFD, the quality and uh, so this part. Let's show you this part. This is what we covered last time. Okay, the videos are all in our channel. Okay, house of quality. Okay, so and the quality of design. So we covered this. And it's basically let's talk about the needs and requirements. So the wants are the requirements of the customer, and the hows are our futures. Yeah, and also here we have the bill of materials boom or boom. Okay, so yeah, so the boom is very important. And I think that's all. Thank you everyone for watching. I hope you benefit from this. Thank you everyone.